This example is a fun one for you to try. You want to find the open intervals on which the curve given by the vector valued function on the domain from 0 to 2 pi. So man, this is kind of like a polar function. We want to find out where this is smooth. Now, a curve is smooth if the components are continuous and the derivative is not 0 for any value of t. So we know the answers here because we can look right here. We have little tiny cusps, or something they call nodes, where a derivative cannot exist. So we know it's going to be between 0 and pi over 2, pi over 2 to pi, pi to 3 pi over 2, and from, of course, t equals 3 pi over 2 to 2 pi. But see if you can solve this using calculus. And on another video, we'll kind of show the solution to this one, okay? All right. But until then, let's take a look at some properties in terms of derivatives and vectors. One, the derivative of u and v is just u prime of v, is just u prime plus v prime. These are kind of hard to see, so. If we look at this one, the derivative of a constant times u is just a constant times the derivative of u. So it's just see you later, alligator. Then we have, of course, our product rule. That's what we have right here. So, of course, our product rule also works. F of t times a function times of derivative is just f prime of t u plus f prime of f of t times u prime. So that's just our product rule. But we also have, like right here, we have a dot product. Now this is kind of an interesting one. The dot product. Now we're going to take a look at an example like this in a minute. But when you're doing the dot product, you can take the first, just like we normally would, times the derivative of the second plus the second times the derivative of the first. That's our dot product. Now remember, this is going to give us a scalar. We'll see an example like that later on. We also have the cross product. How do you get the derivative of a cross product? And the same idea. It's really kind of the same as the dot product. You're going to take the first times the cross the derivative of the second. Whoops, that should be a v. Plus the second cross the derivative of the first. It's just our cross product. Now we're going to find out, there's definitely a shortcut for these, we'll talk about that. And of course then you have your chain rule. So your chain rule will still apply as well. The derivative of the outside times the derivative of the inside. So we have an example here. Given r is this 1 over ti plus natural log of t. Whoops, sorry. It is 1 over ti minus j plus natural log of tk. And r of t is t squared I minus 2tj plus k. And what we're asked to find is the derivative of the dot product. So my suggestion here is do the dot product first. We'll see why we do that in just a second. But let's go ahead and find the dot product. So we're going to come up with so we're going to take r of t, dot that with u of t. And if we do that, we would get, what's that? Just t, 1 over, look at that. So that becomes 1 over t times t squared, which is t, plus, ready? Sorry, so a plus, negative 1 times a negative 2t, so plus 2t. And then natural log of t times 1, so that's just plus natural log of t. Notice, remember, this is a scalar, even though it doesn't look like one, but t, remember, is just some variable right here. And now when I take the derivative with respect to t of r dot u, we're going to get, what's that? That's just 1 plus 2, so we're going to get 3 plus, and the derivative of natural log of t is just 1 over t. And there is our derivative. Now let's say, oh no, I forgot how to do the dot product first. So let's say we decided we want to be a hero. And let's say we want to do it the long way, okay? So we want to take the derivative of t of r dot u. Well, if we use the product rule like we do up here, we're going to get, what's that? The first r times the derivative of the second u plus u dot with the derivative of the second. So we need r of t, which is 1 over t, negative 1, natural log of t. We need r prime of t, which is negative 1 over t squared, 0, 1 over t. We need u of t, go ut, that's going to be t squared, negative 2t, 1. The derivative of ut would be 2t, negative 2, 0. Okay, so my rule, okay, this gets long. Remember, we want r dot u prime plus u dot r prime. So we would take r, which is this 1 over t, negative 1, natural log of t, dot that with u prime, 2t, negative 2, 0, plus u, which is t squared, negative 2t, 1, dot that with r prime, which was negative 1 over t squared, 0, 1 over t. Alright, let's keep going. This becomes, of course, just 2 plus 2 plus 0 plus, that just becomes, what's that, 1, negative 1, plus 0, plus 1 over t, which is 4 minus 1 is 3 plus 1 over t. Notice we do get the same answer in both cases. So the moral of the story is do the dot product first. Do the inside first, especially when you get to the part B when you're looking for the cross product. So we do the dot product first here. So for example B, we are going to, of course, we look at the cross product of the cross product of u and u prime. So we do want to do the cross product first. But this is a little bit different. We want u and u prime. So u of t, we are told is, remember, it is this I see the problem. There should be a u. There we go. So when we look at ut, it's going to be t squared, negative 2t, 1. U prime of t is 2t, negative 2, and 0. Now remember, for a cross product, we are going to get a vector here, so be very careful. So now we're going to take their cross product, I, j, k, t squared, negative 2t, 1, 2t, negative 2, 0. And when we look at the cross product, looking at the i's, we're going to get 0 minus negative 2, so we get 2i minus, don't forget, we alternate signs to get the j's, 0 minus 2t, so that becomes a plus 2tj and keep going, plus, go look at the case, we're going to get, this is a little bit uglier, we get negative 2t squared, and then plus 4t squared. Okay, so this becomes, if you want to write that, I like to write in chevron form, so this is, remember, this is u cross u prime. So we're going to get 2t, and that becomes 2t squared. But remember, we wanted the derivative of this. So it's u cross u prime, and we're going to get 0, 2, 4t. Remember, we will get a vector. Notice, cross product will be a vector. The dot product is a scalar. Alright, come back to part 3 and we're going to start taking a look at some of their antiderivatives. I'll see you then.